Now, if you don't have revenues and the quantum of money that you need has increased substantially, how will you get real investors to support you? So that's why this stage of productization is called the commercialization value of death. So 2020, 2021, early COVID days, cost of capital almost went down to zero. When cost of capital goes down to zero, people lose capital discipline. And that's what we saw in our industry. In addition to that, we had two major phenomena playing out at the same time. Number one was inflation. And number two, as a result of that, was rising interest rates. That's not good for cash flow negative companies that require growth capital.
The electrolyzers that we have today, built for baseload, not built for direct renewables interconnection. And that at its core is what Next Hydrogen is trying to solve for, right?
You should not be sending the hydrogen molecules by putting them back onto the grid and delivering it to them when they don't need it. Hydrogen is a surgical tool to decarbonize those industries that cannot be electrified.
Welcome back to the Interchange Recharged. Electrolyzers are the core technology for the production of hydrogen from water. This is often called green hydrogen when renewable electricity powers the electrolyzers. And after years of hype in the hydrogen industry itself and millions invested for projects and equipment manufacturing to support the industry, hydrogen finds itself in the middle of a path correction, and electrolyzer manufacturers are no exception to that. And they find themselves facing emptier than anticipated production factories and, in some cases, product issues as well, where equipment has been deployed to do real projects. So today we're chatting with an electrolyzer manufacturer who has been scaling methodically from the sidelines. We'll explore what has been going on in the hydrogen industry with electrolyzers, what questions the industry should have been asking all along, and what is a realistic path forward for hydrogen and electrolyzers over the next couple of years. On the show today, we welcome Raveel Afzaal from Next Hydrogen. Raveel, thank you for joining us on the Interchange Recharged today.
Thank you, Bridget, for inviting me. It's great to see you again and looking forward to a candid discussion with you.
Yeah, thank you. And I think we can start off with you and give us your broad perspective on where we are today. As an electrolyzer manufacturer, what is the state of the hydrogen industry and therefore the electrolyzer industry in 2026?
I'd say we are going through the same cycle that the solar industry went through, the wind industry went through, batteries, EVs. So what do you have first? You have, a lot of promises. The products underperform what you expected of them. People thought they could be used for almost everything. It turns out that they have a specific use that they need to be used for. And then, some specific stuff related to us. I think when you think about electrolyzers, you have new use cases for them. You're trying to connect them directly to renewables. That was not the case previously. They were being used for baseload applications. So that's relatively new. Whenever you're going to use an electrolyzer for a new application, there are going to be some learnings. And that has resulted in multiple things, I would say. As you mentioned, we have seen product recalls in the industry. We have seen total installed costs being a lot higher than what people thought they would be. The operational profiles have not met expectations. And then, we have entered a new era where there is no such thing as a green premium under President Trump's policies. So I think this is a natural process. All industries go through it. We are no different. We are going through that process right now. But if you look at the underlying data, we had just about 200 megawatts of electrolyzers installed pre-2020 on a cumulative basis, 200 megawatts. Now we are at about 4 gigawatts, give or take.
Globally?
Globally, yeah. And I would say maybe half of it is artificial demand, really, which is not really connected. So say 2 gigawatts of actual installed capacity. So that's what, a 50% compound annual growth rate? That's not bad. So I think the industry is moving and we're going through the natural learnings that you expect from any new technology.
Yeah, I think it's often referred to as the hype cycle. And I think that's right as well. The hydrogen industry, we've seen it grow, but not grow to the expectations that were originally set out, all of that hype. And when we were speaking previously, I think you used a really nice metaphor. You said that you felt like you were in a dinghy watching billion-dollar yachts go down, kind of referencing other electrolyzer manufacturers that maybe put the cart before the horse a little bit. Can you walk me through what you mean with that metaphor and what these other companies that find themselves in some difficulty are doing differently than your own company, Next Hydrogen?
Let me put this in perspective, right? So 2020, 2021, early COVID days, cost of capital almost went down to zero. When cost of capital goes down to zero, people lose capital discipline. And that's what we saw in our industry. People lost capital discipline. In addition to that, we had two major phenomena playing out at the same time. Number one was inflation. And number two, as a result of that, was rising interest rates. That's not good for cash flow negative companies that require growth capital. So we had that phenomena playing out at the same time. One thing I'd point out, something that I thought was wrong, was that inflation was being tied to clean tech or clean technologies. You saw what was happening to the oil prices rising by about 50% during that time period. What percentage was clean tech responsible for inflationary increase? What percentage was fossil fuels responsible for the inflationary increase? And B, money supply increased substantially. But there was this, big push to tie inflation to what we were trying to do in the clean technology sector, which I thought was unfair, frankly. But it was happening at the same time. But looking back, when you have such macro signals playing out in the marketplace where interest rates are rising, inflation is increasing, cost of electrons, which is 70% of the cost of hydrogen production, for sure was decreasing substantially, but we didn't have access to excess electrons. It's still a challenge right now. So, when you take into account those macro signals, you have to listen to them, and you can have confirmation bias, anchoring bias. It's very easy to fall into those biases and not listen to the macro signals. So I think that was playing a significant role at that time. For example, this is just a case in point. We announced our partnership with Hyundai and Kia in July 2021, I think, and my share price dropped 5%. Market is speaking to you. You need to listen to what the market's telling you. So we listen to it based on not just the share price dropping 5%, but the overall macro environment. And we said, you know what, we have $55 million. We want to deploy it over 1.5 years. That does not make any sense. We need to extend that runway. And so we decided to extend that runway to 5 years. That was very helpful. And, when you're extending that runway, that results in tough capital allocation decisions. And we said, where is the highest return on investment? And we thought, and looks like it was the right decision for us, was let's invest in product development. Let's make sure our technology is good enough so that when you have cheap renewables, but also excess renewables available, we have an electrolyzer that really has a strong product market fit. So that was what we focused on. One of the things that we did was we invested about, I think, close to $10 million in our test infrastructure. And we decided to get our learnings in our test infrastructure rather than trying to get them on the field. I mean, if you try to get those same learnings in the field, it's going to cost you 7x what it costs inside your facility. And the learning cycles are just, night and day in terms of the speed with which you could really move. So I think those are some of the things that we really focused on. We said, let's stretch out our runway, make sure that we focus on product development rather than large scaling and putting out these gigawatt factories, as you rightly pointed out, are still sitting relatively empty.
So you've been focusing on developing the product, finding out which market your technology is most suitable for, as well as testing the equipment in-house. Now, I guess some might argue that testing equipment in-house doesn't actually reflect what equipment working in the field is, which is perhaps why some companies choose to go work in the field. Just out of curiosity, how have the clients that you've been working with, the developers that you've been pitching your technology to, reacted to having so much in-house testing and not really on the field testing? Has that been a positive signal for them?
I think there's no substitute to having reference sites with customers. And we are lucky enough to have one. very close to us, about 40 minutes away with a very reputable customer. So that's great for us at this time. But at the same time, I mean, savvy investors and savvy project developers, they do want to see a lot of data. And, the kind of data that you can generate in-house can be really helpful. And I think you couple the in-house generated data with a reference site, I think it's a powerful combination. But yes, I mean, would I love to have 5, 6 reference sites operating right now? I absolutely would. But, we had to make tough capital allocation decisions, and we focused on what the product needs to do. And fortunately, we have some very good data behind that now.
I want to talk more about Next Hydrogen, but before we dive into what it is that you're offering and how you're approaching the market with this product development under your belt, I want to talk more about what has been going wrong in the hydrogen industry and in the electrolyzer industry as a whole. Government subsidies and funding has been so important to technology development, particularly in North America. And you've previously mentioned that there's a gap in funding between technology readiness levels 5 and then 6 and 7. Can you tell us a little bit about what that means and why that's such a critical problem? What is level 5, 6, 7, and what does that mean in practice?
Technology readiness level 3 is where you have a concept, you may have a bench scale that's operating. Then as you move forward, you get to a prototype stage. That doesn't mean it's a product, it's just a prototype. And then you get into these 5, 6, 7 activities where you're actually trying to productize it, so that it can be ready for commercial deployment. And then technology readiness level 8 would be where you have your first technical demonstration or market demonstration, where you're proving out your first articles. And then following that, once you have done that, then you're in technology readiness level 9. So when you think about getting to the prototype stage, it's a really big achievement. I don't want to understate the importance of that. But it takes you the same amount of time to productize something as it takes you to get to the prototype stage. It's quite a daunting feat to productize your prototype. And the reality is that when you get into productization, your cost will go up by about 3 to 5x what it was at a prototype stage. And a lot of operators don't understand that and are not ready for it. At the same time, when your costs have gone 3, 4x, you still can't sell. You don't have the reliability behind it. If you start selling at that stage, your product for sure is coming back. And that's going to cost you a lot of money. So you don't have revenues. Now, if you don't have revenues and the quantum of money that you need has increased substantially, how will you get real investors to support you? So that's why this stage of productization is called the commercialization valley of death. It's not fun. We lived it. We saw it.
And now you're out of the valley of death?
Yeah. I mean, I'm glad I'm here to tell the story about this commercialization valley of death. It's not fun. And the other thing I'll mention is that there is a lot of government support for, building prototypes. There's a lot of government support when you are, doing market demonstrations or commercial sales for technology readiness level 8, 9 activities. During this valley of death, even the government support is not really there to the extent that you need, because the amount of cash you need is 3, 4x what it is. So yeah, it really is a gap in our ecosystem. I think it's in a gap in many ecosystems. And I really hope that if we want to really monetize our innovations, the government start focusing on this commercialization valley of death that so many companies go through.
And so to clarify, right now you find yourself at Next Hydrogen around technology readiness level 8, where you're kind of doing your first commercialization. That's that customer that you mentioned.
That's right. Yeah.
Excellent.
Yeah.
Congratulations on surviving. And you mentioned governments have this kind of funding that's available, but governments are also kind of sticking their foot in the electrolyzer industry as of late in terms of policy, content requirements in Europe that we've seen come through, certain content requirements for European produced equipment. if applying for a European-based subsidy. And the reason why this has been so important is because Chinese electrolyzers have been offered at about a quarter of the price that we've been able to see come out of the North American market, the European market. And as you mentioned, electrolyzers are capital intensive, though they aren't the number one contributor to the overall cost of the hydrogen, which is the ultimate output of the electrolyzer. Nonetheless, Chinese OEMs are able to offer equipment that meets requirements of American and European developers at prices that it seems Western manufacturers can't match. Can you walk me through how Next Hydrogen is thinking about this? What is the difference between a Western electrolyzer and a Chinese electrolyzer?
Yeah, I think it's a really good question, and it requires me to dive deep in a few topics. So I'll do that. First of all, I'd say that whenever you have any new innovation and you as a country decide you want to focus on it and you want to export this innovation and you want to grow this industry, grow manufacturing jobs, increase your skilled labor, you should support it to some extent, so that when there are big projects that are happening, your innovators get a chance to participate in them. It may be that another continent or another place may have stronger policies and they have had much larger adoption rate. So people in that country or that continent may be moving a lot faster than your innovators, and your innovators may have a great product tool too. So you need to give them a chance to at least participate in these projects so they can demonstrate what they have and at least have a chance to scale. If you're not going to give them a chance to scale, I think you are going to lose as a country and probably not participate in any new innovation or any new industry that's coming out. Now, I don't think it should be 100% local content requirements, because that's not fair. It's going to result in people operating in an inefficient manner. But there should be some, and I hope they do that in Canada too. I think it's important. It's important for our industry overall. Now, the second point I'd make is, there is this common misconception that Chinese products are inferior and Western products are superior. I call it like a pre-2020 thinking. It's so different now. And, when you go to China and you see the products that they're putting out, it's very impressive. And I think we should give them respect for that, and we should acknowledge that. So I think, we need to move away from, hey, their product is inferior, our product is superior. It's not true. But what is true is different suppliers are using different materials. And that needs to be acknowledged. And I can give you multiple examples of that. Like, some people could use nickel-coated parts. Other people are using pure nickel parts.
What happens when you use different coatings for these plates?
I'll speak about an alkaline electrolyzer, for example. It's a highly corrosive environment inside. And I think I need to spend a few minutes speaking about this. This is a really complicated engineering feat, what we are trying to do over here. It's oxidizing on one side, it's reducing on the other side, it's 70 degrees C or higher temperature inside. It's a pressurized vessel. It has QOH in there, and then you have hydrogen and oxygen on both on either ends, right? So, and they better not mix. So it's a really, really complex engineering feat. What companies like us are really doing. Let's speak about where we were. So say you have a nickel-coated part. What if you get a pinhole in that? You get a pinhole in that nickel-coated part, it's going to corrode very, very quickly. It'll be worse. It'll be better if you didn't have any nickel coating on it to begin with. That's how bad it would be from a corrosion point of view when it gets in there. So that's one example.
Does that represent like a safety concern or more of an efficiency concern on the performance of the equipment?
I think it's a safety concern. I think your equipment's just not going to last. It's going to rust away very, very quickly. It's going to have cascading effects throughout the system. You're also going to start getting contamination, for example.
The main difference then is what you're suggesting between Chinese equipment and Western equipment is depending on the quality of materials that are used for the construction of the electrolyzer. There can be differences in how this equipment holds up over time. However, you also alluded that China is capable and has been producing very high quality components and equipment. So what's the conclusion here? Is it something that developers, if they're interested in purchasing Chinese equipment, that they should watch out for the quality of material components used? Or is this something that Chinese equipment manufacturers are really paying attention to improving?
I would get away from Chinese versus Western. I would say they should look at all electrolyzer companies and ask such questions about what materials are you using? What membranes are you using? Talk to me about your balance of plant. What type of functional safety do you have in your balance of plant? How quickly can you detect gas purity issues? I think these are, what about the catalyst that you're using and how do they operate intermittent? What type of degradation mechanism do you see intermittently? I think this is a question we ought to ask all electrolyzer providers, and let's not single out the Chinese electrolyzers, for that. So that's where I would go with that. Then finally, you asked, what is Next Hydrogen trying to do differently? And I think the number one way to reduce the cost of these electrolyzers is by increasing current density. So what does that really mean? It means that you want to produce more hydrogen out of each cell compared to your peers. So if you put a high current density electrolyzer, say it can produce 3 times more hydrogen compared to other electrolyzers, it'll be 1/3 the footprint of another electrolyzer which is operating at low current density. That really means that you're using less materials to produce more hydrogen. Higher material utilization to reduce the capital cost of these electrolyzers. So there's 2 pathways. One is you use low cost materials. B, you could use higher material utilization. And the best world would be where you could have low cost materials, but high quality materials and use less of them. That's what Next Hydrogen is trying to do. In fact, we are not even using any nickel parts. We are using specialty engineered plastics, which have been used in the hydrogen industry forever. So we don't have to worry about these corrosion risks to begin with.
Okay, so this is interesting because you mentioned we should be paying attention, or developers should be asking equipment suppliers really just about what components are being used from an electrochemistry perspective. But I guess my question would be, and you kind of hinted at what Next Hydrogen is doing here, does higher quality parts always mean higher cost?
No, not really. You can get specialty engineered plastics and injection mold them, and they'll cost you the same amount, if not less, compared to nickel parts. And in fact, will weigh less too. It doesn't mean that. I think innovation is very, very important, and I think that's one of the best ways to reduce the cost of your electrolyzers. It doesn't really mean that. So I think it's a good clarification, Bridget. So I don't think low cost equals low quality always.
Okay, and this special plastic that you're using in your equipment, is this very unique to Next Hydrogen, or why isn't anybody else? Why haven't I heard of plastic membranes before? Who else is using them?
It's not plastic membranes, it's plastic structural plates. So typically what you would see is a nickel bipolar plate, and we are using basically specialty engineered plastics. In fact, they've been used in the industry for a very long period of time, these specialty engineered plastics. So we are not using a brand new material in the hydrogen space. They have never been, injection molded to these large 6-foot tall parts like what we have really focused on. So speak to an automotive company manufacturer. They'd say, I'd love to have one big injection molded car body that I can use. That would be perfect, in terms of reducing the cost of those cars. That's what we have really done. We have come up with these large injection molded tools made of specialty engineered plastics that are used in the hydrogen industry, have a good track record in there. And it took us a long time to get those parts right.
We've talked a little bit about the advantage that Next Hydrogen has in terms of lowering cost, increasing efficiency through the electrolyzer. But I want to go back to another point that you mentioned at the beginning in relation to product recalls and some of the referenced issues. You also hinted at the fact that maybe there's about 4 gigawatts online today, but only 2 gigawatts actually real demand. Can you clarify what those points mean? Or is there an example in mind when you talk about product recalls or a project that has had an issue, and what's actually gone wrong with electrolyzers in the field?
I can speak about what has been published in the industry, and and we want to be constructive. We want to grow this industry, right? But at the same time, we want to be realistic, because I think the best way to go to the industry is by meeting customer expectations. That's the most important thing. So what we have seen is that the membranes that have been used in the industry are cheaper quality membranes compared to zircon membranes, for example. And we have seen that the turndown that the project developers expected did not get the turndown. What does that really mean?
Yes, what does turndown mean?
Yeah. So say the maximum output of an electrolyzer is, I'm making it up, like 100 kilograms per day. Now, if you connect it to solar and wind, you want to be able to cycle up and down. And so say the expectation was that you could cycle it down to 20 kilograms per day. So when this cloud cover, you can bring your electrolyzer all the way down to 20 kilograms per day. That's turned down. So 20%, right? And we have seen that the use of these cheaper membranes, for example, have resulted in turndown being much higher than they expected. So they don't have the operational flexibility to load follow renewables the way that they expected. And why is this an issue? Because when you bring the electrolyzers down, you start getting gas purity issues. So if you don't use good separators or good membranes, you're going to start getting gas impurity, and gas impurity can result in safety issues. So you have to be very careful about that. That's one example that we have seen. The other thing we have seen is in terms of reverse currents impacting electrolyzers. When you turn an electrolyzer off, the anode becomes cathode and the cathode becomes anode, just for a little bit of time. But that's enough to cause degradation of the catalyst. And as a result, you'll start seeing cell performance not meeting expectations over time. You'll start seeing a greater impact of these degradation mechanisms. I think we've seen that, and that's natural because, as I mentioned early on, a lot of these electrolyzers were baseload application electrolyzers. They didn't have to be turned off. You turn it on once and it's operating within a very narrow operating window, and that's really good. But when you're going to take an electrolyzer and now say, hey, I'm going to operate you intermittently, it's going to result in new challenges. These are not fundamental challenges. These are engineering challenges. And I think the industry will get over it. Some of us already have, and others will soon get over them.
So I just want to recap the two issues that you mentioned because they seem to be related. So there's the turndown issue. So when a cloud comes over a solar panel that's directly connected to an electrolyzer, instead of the electrolyzer being able to respond to that current decrease, it would have to turn off, you're saying. And in turning off, it has that gas contamination with the anode turning to the cathode to the anode, and having this reverse current causing this gas purity issue, right? So the electrolyzers that we have today, built for baseload, not built for direct renewables interconnection. And that at its core is what Next Hydrogen is trying to solve for, right?
Precisely. And very well put, Bridget. And I would say they can be, as you pointed out, like one issue, meaning that you can't take it down to 20% and you have to turn it off. Or it could be independent issues too, that electricity prices are low during specific period of time, and as such you only want to run it during those periods of time, and other times you want to turn those electrolyzers off, or you want to bring them in standby mode. I would say we have seen issues like that, or we have heard about issues like that in the industry. Other things we have seen are PEM electrolyzers. So alkaline electrolyzers were primarily made for baseload applications. You have seen one in Egypt, S1 dam, been operating for so long. There's such great track record with alkaline electrolyzers for baseload applications. And then you have PEM electrolyzers, which were primarily made for NASA-like applications, right? So now you have a situation where you're taking these electrolyzers, PEM electrolyzer made for a very specific application, compact, very high current density operations, but made for a very specific application. We are trying to mass produce them and use them for direct connection to renewables. And you have these alkaline electrolyzers, which are made for baseload applications, but already like very, very intrinsically large scale. They can operate at very large scale, and they have a great track record of it. We are trying to use them for intermittent operations, right? So you're trying to shoehorn electrolyzers, which were purpose-built for different applications, into a new application. And that can cause some challenges. And I think we have seen some of those challenges in the industry.
So speaking about your first system, which I believe you got operating in August last year, can you tell me a little bit more about that? Is this project that you have paired with intermittent operation?
We have operated it intermittently, yes. And not only have we operated it intermittently, we have run tests for our independent system electric operator over here, our IESO, to show our dynamic response, our load following capabilities with this electrolyzer. The electrolyzer overall is grid connected because, we have such clean grid here in Ontario, but we have been able to run our electrolyzer based on the signals that our IESO has sent us to demonstrate intermittent operations. But I think there's more to it than that, right? Before we got the system in the field, we got over 40,000 hours worth of data, from different types of builds and operating these systems in very different manners before we brought it out in the field. I'm just looking out my window and I see these Toyotas standing in my parking lot, office parking lot. That's the kind of brand name I want for Next Hydrogen. We are here to be a reliable provider of high quality electrolyzers. Innovation is not good enough. Innovation plus reliability is what we want to deliver. So we spent a lot of time dealing with exactly these kind of issues. So we followed EU protocols for durability tests. We were running these electrolyzers 100-hour on, 100-hour off, over 5,000 hours to understand what we need to improve. How do we better manage reverse currents? How do we increase the current density safely of these electrolyzers? So we really focused on that, and then we delivered this system out. But we have a few more to deliver now.
Are those projects that you have upcoming grid connected, or will they be off grid and have this kind of intermittent load that you're talking about?
The electrolyzers we have upcoming will the ones that we have in front of us right now are grid connected electrolyzers that will be operated intermittently because they're going in material handling equipment. So they're going to distribution centers. And I want to see more solar on the rooftop of these distribution centers. It makes a lot of sense. People are focused on that right now. But we are deploying very close to home right now in Ontario, and some of these are grid connected. But that does not mean that they will not be operated intermittently. You see, like the pricing during the day can be 11 cents, and at night it can be 4 cents. So it's a huge difference. And I think we will need to be using electrolyzers when cheap and excess electrons are available. That's where hydrogen shines.
Right, which can either act as some kind of grid arbitrage or renewables curtailment. And I guess considering that we've talked about a little bit of grid connection, maybe direct renewables connection, what is it that you see as the future for hydrogen production? You said when costs are cheap, but when Next Hydrogen is the Toyota in the parking lot, how is your equipment running?
Directly connected to renewables. Based on first principles, that's what makes the most amount of sense. Let me explain. The kind of growth rate we are seeing in renewables is incredible. I think we are something close to 745 gigawatts now of renewables. And Bridget, I grew up in Pakistan. I think they put something like 20 gigawatts of solar last year on the rooftop. To the point where I think they are implementing a solar tax maybe, and the utilities are struggling. And this is a country where you had load shedding, right? And it was okay to have blackout for a period of time. Every day. We are in that phase right now where solar and wind are in the 3 to 4 cent range globally, and that growth rate is not going to stop. However, we are going to see more and more that you can't put these cheap electrons onto the grid. The grid just cannot handle it. We are seeing these blackouts, we're seeing these burnouts as a result of that. So that is exactly the kind of environment where hydrogen can play a role. Now you have these excess electrons available. You can't put them on the grid. Let's use these electrons directly to produce hydrogen. And that's where I think where the value proposition is going to shine. So where we are now, we have cheap electrons, and now we are moving towards excess electrons that cannot be put on the grid. And that's going to be a great business case for the hydrogen space. I also think, we can think about it based on first principles. There's a cost for the grid. There always will be. You have to maintain those grids, especially in North America. I mean, those grids are old, right? So the toll tax, so to speak, on the grids is only going in one direction. So if you don't have to pay that toll tax and can connect these electrolyzers directly to renewables, I think that's where the real value proposition is. And, now we're converting these electrons into molecules and moving them directly to where they're needed. rather than mass distributing them where they're not really needed.
And we've seen projects in India, for example, waive these grid tariffs, these toll fees, and then these projects also benefit from selling power back to the grid from the renewables that are connected to the electrolyzers and to the grid. They can sell the power as additional revenue, not just the hydrogen. And I think I've heard an argument before that electrolyzers could also stand to provide grid stability services. What's your take on that?
We have just done that with our independent electric system operator to show how we can be used for frequency regulation, for example. The way I think about this is that, so say during the course of the day, in the afternoon or something, or really at night, when the wind is blowing and you don't have that much demand, now you're trying to put a lot more electrons onto the grid when compared to what you need. Or maybe the grid cannot handle it. So sucking those electrons off the grid makes a lot of sense. And then my view is that you should be taking those electrons, converting them into hydrogen molecules and delivering it to those processes that cannot be electrified. If a process can be electrified, you should not be sending the hydrogen molecules by putting them back onto the grid and delivering it to them when they don't need it. Hydrogen is a surgical tool to decarbonize those industries that cannot be electrified. And B, the second point I'd make is just think about the round trip efficiency. It's not great, right? So if you're going to convert it first into hydrogen and then put it back onto the grid, the round trip efficiency is not in your favor. So why not, take those electrons that cannot go onto the grid during certain periods of time and put them into hydrogen molecules and then deliver it directly to where it's needed rather than mass distributing something.
So then where does hydrogen actually make sense to you if it's a surgical tool? Where is it that industry is chasing applications now that do and don't pencil out?
I think the most important question I like to ask project developers first is, what is your levelized cost of electricity? And I think that will dictate the answer to that. So you see, like, as you know, Bridget, it takes about 50 kilowatt hours roughly to produce each kilogram of hydrogen. And that's going to be 70% of the operating overall cost of hydrogen production, roughly speaking. So let's just do rough math on this. We take 4 cents electricity price and say it's available almost all the time. You are looking at 50 into 4, so about $2 in terms of operating cost. Then add in a little bit, you're in the $3 per kilogram range. That's very attractive compared to fossil fuel based hydrogen. You're very close to that number. It would be better if you're in the 3-cent range, but you're very close to that. Those numbers. And then you could say, yeah, I'm going to use it for industrial scale applications. I'm going to use it for ammonia production. I'm going to think about using it for refinery operations without perpetual subsidies, right? Because we don't want an industry which requires perpetual subsidies. And that's not what our business model ought to be, or, what Next Hydrogen focuses on. Now, if you have, say, close to 6-7 cent electricity price, then you're probably in the $6 to $8 per kilogram range. And then you're better suited for transportation applications because you're competing effectively with diesel. So I think that's really where your cutoff points are. Once you start going above 6-7 cents electricity price, I really think the business model starts failing.
We've seen really impressive hydrogen and ammonia prices come out for green hydrogen, green ammonia, electrolytic-based projects, especially in China, in India, over the past couple of years. But I will say getting to $3 per kilogram back calculating from that is real tough. And it's not just about the electricity price. It's also about the capital intensive cost of the electrolyzer itself. In order to get to $3 per kilogram, what is the target dollar per kilowatt total installed cost, balance of stack, balance of plant? It's on site, it's operational. What does that dollar per kilowatt cost have to be in your view? So
let's think about where the prices are right now, and it depends on the scale of the project. Right. So you say massive project, and we say it's around $500 per kilowatt, stack plus BOP. And you're amortizing it over 15 years. Maybe the stack gets replaced every 8 to 10 years, and then the balance of plant lasts 20 years. So do some rough math on that. What does that equate to? I think that equates to about 50 to 60 cents per kilogram. The rest is all OPEX. And OPEX, we said, take 50 kilowatt hours on average and multiply it by what the price is. But you raise a really good point. Why is the install cost so much higher then? Why is it taking so much? And I think that's where the industry is really focusing on. Before, we thought we are going to take all these big stacks and we're going to put them in buildings and it's going to be really cost effective and that's how we're going to scale. Well, I think there's a lot to learn from the solar and wind industry about the modularization that had happened in that space. And I think that's what you're seeing in the hydrogen space as well. We are looking at how we can deliver plug-and-play containerized solutions to the site to reduce that installation cost. And I think that's contributing almost, in some cases, 1x to 1.5x the cost of the equipment. And it's also because EPCs are just learning how to use electrolyzers. And of course, their margins are so thin to begin with, so they have to overestimate what the labor hours are going to be, what the on-site installation costs are going to be. So I think that's playing a role in there too. And I think everyone's learning at the same time. There's a lot of integration of first of a kind engineering that's happening at this time. Somehow it needs to end up in the project. So I think all of those factors are playing a role in there. But you see, solar went from 40 cents down to 3-4 cents. And I can tell you firsthand, we are looking at this data ourselves. The hydrogen is following a very impressive cost curve on the capex side, and our opex is the solar and wind price. So it's already come down substantially. So I think the tailwinds are there for the hydrogen space long term. But we just need to make sure we deliver on what we say we are going to deliver to our customers, so that we make sure that this hydrogen industry has a great reputation, and we are able to achieve the kind of things that we want to do with hydrogen to decarbonize our economy in a sustainable manner.
Well, I'm curious about this modular solution for electrolyzers, because it sounds like you mentioned that the EPC companies are really responsible for installing and delivering that equipment. Hence the 1 or 1.5 times the cost of the actual equipment cost. But you also mentioned that, compared to solar, electrolyzers are a huge engineering feat. So I guess my question is the future of this modular delivery of an electrolyzer coming from a vendor like Next Hydrogen? Are you guys doing everything? Does the EPC still have a role in the future? How is it that you're going to remove that huge cost multiplier from the EPC?
I think the future will look like electrolyzer module, balance of stack, and balance of plant. And balance of plant is what the EPCs will do. So think big cooling systems, big reverse osmosis systems, things like that. So they'll be focused on that. The balance of stack will have how to control the electrolyzer module in there, something which is specific to the operations of those electrolyzers. I think the future would be that you'd have electrolyzers and a balance of stack, which is pre-commissioned, plug and play, containerized solution that is delivered to site. That's where I think, and it's going to be in standard ISO containers. I think that's where the industry is going. And which is why I think, current density is so critical. So you put my electrolyzer next to a conventional alkaline electrolyzer, I'm 1/3 the size. So my 1.5 megawatt electrolyzer, is equal to the amount of space a 4 megawatt electrolyzer will take. And guess what? You can't containerize that 4 megawatt electrolyzer. It's not going to fit in a standard container. So it must go in a building. So going to high current density operations to make these alkaline electrolyzers, which are already low cost, which can already scale, which already have the track record and durability behind them, but making them compact so that they can fit in a containerized solution delivered to the site, I think can play a significant role in reducing the total installed cost. And I think that's how we should always be thinking: total cost of ownership.
Correct me if I'm wrong, but my understanding about electrolyzers, 5 years ago was that they were containerized. That was what was being sold for specialty applications where you needed pure hydrogen gas. It was, small market, but sold in a container. And then it seemed like industry shifted outside of the container, but now we're kind of boomeranging back. We're going back towards the container to deliver these like turnkey modular solutions. Like, for example, we saw ITM Power, they had announced their turnkey solution earlier this year that's at a much larger scale. Am I crazy or did that boomerang happened, right?
Bridget, you're absolutely right. The thing was that the stacks were so small at that time, right? So you could easily containerize them. You could have a zero point 0.2, zero point 0.3 megawatt system going in a containerized solution, and you can containerize it. And I'm speaking about alkaline specifically. And those were going into exactly that. Those are industrial gas market, semiconductor, glass making, those kind of applications. But the issue is you can't put zero point 0.3 megawatt electrolyzers into a 100 megawatt project. So if you're going to take that same current density and you want to put like even a 2 megawatt stack, it's not fitting in a container unless you can increase the amount of hydrogen you're producing out of each cell. And so that's what the industry is moving towards. If you look at US Department of Energy and you ask them, and it's in their reports, where's the industry moving to and what's the most potent way to reduce the cost of these electrolyzers going forward, they would say current density. It's the most important thing, I think, but doing it reliably. And the issue is typical alkaline electrolyzers are going to struggle with increasing the current density.
Okay. So I guess the way to visualize it is for those that aren't familiar with electrolyzers, computers back in the day used to take up a whole room just for one computer, and now we've got something that can sit on our desk, and that's where the electrolyzer industry is hoping to go towards.
Well put.
Okay, just to clarify. And I guess my question for you then is, it seems like Next Hydrogen, you've spent the past couple of years focusing on your product development. You've got your first customer, you've got more customers to be announced later this year. What does the next 2 to 3 years look like for electrolyzer manufacturers on the whole? How many companies survive this valley of death? Will there be consolidation? And then where do you see Next Hydrogen fitting into that landscape, considering, you're a bit of a late bloomer in the sense that you're coming later with commercial scale projects?
I think the most important thing for all manufacturing businesses, especially in early days, is to keep their fixed costs low and focus more on variable cost model. So companies that have not been able to do that and they're stuck with very large facilities right now, they won't even get consolidated. Just the OpEx is too high, right? So unless you have a really differentiated value proposition and a very, very, very different IP, I think it's just not going to work out. So I think companies that are going to survive for the next few years, and by the way, there are projects, and there are enough projects that if you manage your working capital well and you are disciplined in terms of capital allocation, you can be cash flow positive, even in this environment. So I think that's what I would say. I think companies with low fixed cost, thinking about variable cost model, thinking less about horizontal integration and thinking more about vertical integration, I think those are the kind of companies that are going to succeed at this time. And companies, business 101, be straightforward with your customers, tell them what you can deliver, and then make sure you over deliver compared to what customers want. I think that's how you win. Just the cost of customer acquisition is so high that you don't want to lose your existing customers, right? So I'm proud to say we are now working on our tangent. This customer that we just delivered to, we delivered a system to them previously, and now we have 2 more orders with them, right? So I'm very proud of that, and we just got our 3rd contract in the nuclear space. Relatively same customer, so we care deeply about being customer centric, and I think that's how you win.
I think something else that we've heard from developers is that they want to partner with a manufacturer who they know is going to be around 15, 20 years from when they start their project, to ensure that they have that safety net. From Next Hydrogen's perspective, right now you're based in Canada. You said you're focused on deploying nearby. Will that change in the near future? Do you see enough projects deploying in Canada to support your ambitions?
To sustain my operations, absolutely, and probably way more than sustain my operations. I think Canada is likely going to take a lead over the US in terms of electrolyzers deployed. It's not a good benchmark, a big benchmark to set right now, and hopefully it changes. But I do see the places where electrolyzers are going to be deployed, as I mentioned, will be where you have 4 cents electricity price or below, you have excess electrons available, and you have end users nearby. I think that is the perfect regions where electrolyzers are going to be deployed. So think North Africa. India, I think, is doing a great job in there. Some pockets of Middle East are really exciting. So I think those are important markets, and you need partners to access. And China, of course. You know, uh, I think you need partners to access those markets. And so, as I mentioned, we care deeply about focusing. And my executive chairman says this all the time. We are going to focus on what we are really good at, and anything that we are not good at, we're going to partner with the best. And that's what Next Hydrogen is focused on. We are really good at designing electrolyzers. Am I the best to deliver, manufacture electrolyzers? Am I the best system operator? I think there's many other players that you can partner with that can give you access to, that can provide you with access to these markets, and also help deliver a superior product to the customers that they're happy with.
Now, you mentioned that a couple of regions in which hydrogen projects can really excel, maybe unique permutations in which you have everything low cost of renewables, proximity to your end users. So tell me then, looking out 5 years from now, what does a healthy hydrogen industry look like? What does a healthy electrolyzer industry look like? Is it that these projects are focusing on these low cost geographic locations and hydrogen's being transported? What's your realistic scenario for 5 years from now if we're on the up and up?
I would tell you, like, my 2-year window, 5-year window is very difficult for anyone to really see.
I can understand that. 2 years, go ahead.
And then you have a 10-year, a long-term vision for where hydrogen goes. I think near term, you're going to see more of these 10 to 50 megawatt projects that really make it, because the quantum of capital that's required is substantially low. And larger players can experiment with those kind of solutions, even if the cost is slightly higher. I think longer term, we are going to be in areas, as we pointed out, where electricity prices are relatively low, and we'll start using them for maybe methanol, e-methanol projects, sustainable aviation projects. To some extent, maybe as we further grow ammonia. I think shipping over long distances can be a bit of a challenge, and I think it's going to remain a challenge for us. So I think that's really going to matter. I think the winning value proposition is going to be where you have low cost electricity, anchor customers nearby, and you're producing excess hydrogen, because then you can take that excess hydrogen in a hub and spoke model, supported by an anchor customer, and deliver that excess hydrogen in 150 kilometers or something like that, and even in gaseous form. I think that's going to work out. But then if we think really, really long term, I think solar is absolutely going to be the dominant force of electricity production anywhere in the world. And you're going to start seeing microgrids. And I think hydrogen will have an important role to play in those microgrids. I think energy resilience is extremely important. And I think, unfortunately, this Iran war was just, if this was not a wake-up call, I don't know what is, in terms of what energy resilience really means. And I think the distributed grid model is really going to take off. And I think hydrogen will have a vital role to play in that. And then when I think really long-term, I think energy storage, but long-duration energy storage. I think hydrogen will have a role to play in there. And again, based on first principles, megajoules per kilogram, it starts to make sense when you're looking at shoulder periods, very, very long, 5 months, seasonal storage applications. I think hydrogen will have a role to play. So let's sum this up, right? We start off with these 10 to 50 megawatt projects. Eventually, we get to these anchor projects where we have anchor customers. We are building out these excess facilities with them. It's in low cost electricity prices, and those can be relatively big facilities for us. And I think, things that can sell for $5 per kilogram, $6 per kilogram. I think that's where you'll have a really good market early on for the hydrogen space. And then longer term, I think with microgrids, that's going to be big, and eventually long duration storage.
So when you say early on $5 to $6 per kilowatt, is that in the next 2 years?
You mean for sustainable aviation fuels and those type e-methanol applications?
I guess I'm just wondering, what you think, because you'd mentioned, $3 per kilogram kind of being a target cost, and those numbers always get thrown around. What is it that you think is a reasonable cost today? How does that, because it's always going to be a cost curve. You see the cost come down, demand go up, right? So where do you see on the timeline for, where does this $3 per kilogram sit? Where does this $6 per kilogram sit? Where are we at today on average, do you think?
Yeah, I think cost and price are different. So I think that's what I was really referring to, what your cost of manufacturing is. And then, of course, you need to get your IRRs on that. I think early on, the IRRs are going to be relatively good. I mean, you go through this valley, right? Like initially, you have a lot of challenges with your products. The projects fail. Then you understand how to build these projects. And then you're looking at IRRs. Even unlevered IRRs can be as good as 30%. We saw that in the solar days. Now, levered returns in the solar space are 9% levered returns. All right. So I think we're going through that cycle, and we'll see the same cycle for the hydrogen space. I think people who can stick it out and are disciplined in terms of the projects that they chase, I think they're going to do really well. Again, I think once we get to these three key things that I'm looking out for that are really, really important, can we get access to excess electrons? I think there's no question electrons are cheap now. Can we start getting access to excess electrons? I think that's going to be a boon for our industry. Number two, can we deliver containerized solutions to our customers? And number three, can we deliver intermittent operations reliably when you connect directly to renewables? I think those are the three big buckets that we need to focus on. I think, Bridget, we're already seeing CapEx come down substantially of these electrolyzers. Even for me, when we started this company, when I joined this company in 2021, I think the CapEx of my electrolyzers is down more than 40%. And I think right now we're seeing another 40% drop.
Is that on like the 1 megawatt scale?
It applies everywhere because it's the same supply chain, same components. So for sure, with electrolyzers and with balance of plants that go with it, I think you will get really good capital cost reduction. So I'm not worried about that. What I'm thinking about is, do you have access to the feedstock? Can you deliver containerized solutions so that we can control what the total installed cost is? And can you have electrolyzers that can operate up and down and be turned off when high electricity prices are there? I think those are the three things to really watch in this space. And frankly, I always tell my team, think not in terms of cost, think in terms of cost performance. I don't care about being the lowest electrolyzer provider. I do care about having the best cost performance value proposition for my customers.
That's how you're going to win customers right there. My last clarification question, I guess, would be, when you said we've got this basically next generation turnkey solution, containerized solution, when can we expect that to take the market by storm? When can we expect to see, the $1,000 per kilowatt total installed cost, or whatever benchmark you think is reasonable to achieve a good cost? But when can we expect to see turnkey solutions take the market by storm? Is that something that all electrolyzer companies are working on?
I think all of us are working on it, and I think it's coming now. Really, I think these kind of solutions are in the works, and they're coming very, very soon to the marketplace. The pace of innovation, and we are all competing, and we are all working very hard. And I'll tell you, like during a downturn is the best time to look at which companies to focus on, because in an upturn, everyone is an expert. Everyone knows what they're doing. Everyone has great quality product. It's very difficult to discern between who really has the moat. So I think this is a good time to see who is really leaning into this industry and who really has the expertise and the pedigree to deliver long-term solutions. And I just say, I think it's important to take a close look at our cell design architecture. We have been building electrolyzers since 1990s. We built electrolyzers, alkaline electrolyzers, we built PEM electrolyzers. We were part of two companies. Both of those companies got acquired. And, we took all those learnings from decades of building electrolyzers to come up with this electrolyzer design, which is purpose-built for direct connection to renewables. And we got 40 patents on it. And it's really, in my opinion, a real notable change in the cell design architecture, quite a notable change in the cell design architecture. And we worked on this in 2008. That's when we started working on this. And we said, in the future, electrolyzers will need to be directly connected to renewables. It took us a while to get there, but I think the future is there, and we have a product that really meets the market need. So I'd encourage people to look at how unique our electrolyzer really is.
Well, thank you very much, Raveel, for joining us on the podcast today. This has been a very refreshing conversation, uncannily positive about hydrogen, given the market as of late. But it is going through a difficult transition. There is hope to be had, and thank you for being willing to talk honestly about what has worked, what hasn't, what you're doing, and what comes next. So thank you for joining us.
Thank you so much, Bridget, for the opportunity, and look forward to staying in touch with you.
Thank you. And thank you, audience, always is joining. You're welcome to listen to and follow along the Interchange Recharged wherever you get your podcasts.